Welcome to Do the Math America. I am Charlene Math Shaman. I work out of New Elementary Mathematics, Syllabus D. You may find a copy of this textbook from singaporemath.com. I have included a link in the description box below this video where you may find a copy of this book to purchase. I cover angle properties of a triangle from pages 262 to 266. Math must be learned sequentially. If this material in this lesson does not make sense to you, please watch my earlier videos and do the practice problems to get up to speed. Consider triangle ABC. The line PQ is parallel to AB. I add the arrows on PQ and AB to remind you that these are parallel. Is angle PCA plus angle ACB plus angle BCQ equal to 180 degrees? So PCA plus ACB plus BCQ equals 180 degrees. Is that true or false? So I go back to the figure and highlight PCA right there on the upper left. ACB is the middle angle on top, and BCQ is the angle to the right on top. And you can see that all three angles are adjacent angles on a straight line. Therefore, they do add up to be 180 degrees. Because adjacent angles on a straight line are supplementary, so this statement is true. And I write the abbreviation for the postulate adjacent angles on a straight line underneath to support the above equation. And here I draw your attention to the gray box on page 239 that summarizes some of the geometry postulates we will be using in this exercise. We will use their abbreviations to support our reasoning as we solve these geometry problems. So the postulate adjacent angles on a straight line can be found on page 239. And I discussed this concept in greater detail in lesson 49. Okay, back to the figure. Now we consider, is angle PCA equal to angle CAB? So the statement, angle PCA equals angle CAB, is that true or false? So I highlight those two angles using the orange marker, and you can see that those two angles are created by a transversal cutting across two parallel lines, and PCA and CAB are alternate angles. And as I discussed in lesson 50, alternate angles are equal. So the statement PCA equals CAB is a true statement. And I write out the geometry theorem. When a transversal cuts two parallel lines, the alternate angles are equal, which can be abbreviated as alt angles to support the statement that angle PCA equals angle CAB. And this theorem can be found on page 246, and I discuss it in lesson 50. And I refer you to the gray box on page 246 that summarizes and abbreviates these theorems and corollaries. And in case you're having a hard time seeing that angle PCA and CAB are indeed alternate angles, I will extend segment AB as well as segment AC to show you parallel lines AB and PQ being cut by the transversal AC. Next, we consider, does angle BCQ equal angle CBA? So angle BCQ equals angle CBA. Is that true or false? And I highlight angle BCQ is the top angle to the right, and angle CBA, it is the bottom angle to the right. And since we see that BCQ and CBA are also alternate angles, it is true that they are equal. And I write the abbreviation for that postulate or theorem, alternate angles are equal, to support the statement that BCQ equals CBA. So since both lower angles of the triangle are equal to those outside angles on top along PQ, they are therefore supplementary to the top angle of the triangle. And we can say that the sum of three angles of a triangle is 180 degrees. That statement is true. And I also introduce you to the Latin phrase quod erat demonstrandum, which is abbreviated as QED, which means that which was to be demonstrated or proven. In other words, we have proven this concept. This used to be part of classical learning in Western civilization. And this theorem is summarized in the gray box on page 262. Now we examine triangle ABC, in which side BC is produced to point X. As a result, angle ACX is formed. Angle ACX is called an exterior angle of the triangle. Angle CAB and angle ABC are called the interior opposite angles of ACX. So I label angle CAB and angle ABC as interior opposite angles of angle ACX, the exterior angle. Now take a look at angle ACX. Is that supplementary with angle BCA? In other words, does angle ACX plus angle BCA, does that equal 180 degrees? And I will highlight angle BCA for you. And you can see that angle ACX and angle BCA are adjacent angles on a straight line. So the statement ACX plus BCA equals 180 is true. And below that equation, I write the abbreviation for the axiom, adjacent angles on a straight line, to support ACX plus BCA equals 180. Next, we notice that the angles of the triangle also add up to 180. So angles ABC plus angle CAB plus angle BCA equals 180. And that statement is true because of the theorem, the sum of the angles of a triangle is 180. So I will relabel those angles for you so that you can see exactly what this equation is referring to. Angle ACX is the exterior angle. Angles ABC is the one on the right within the triangle, and angle CAB is that one on the left, and BCA is the angle on top. So we can see that those angles do add up to 180. And I write the theorem underneath to support that equation. the sum of angles of a triangle is 180. Or you can just write the abbreviation in parentheses, angle sum of triangles. So, since we can see that both ACX, the exterior angle, is supplementary with BCA, that is, those two angles add up to be 180, and the interior opposite angles, when added with angle BCA, also equals 180. Therefore, we can say that ACX, the exterior angle, equals the sum of the two interior opposite angles, ABC and CAB. And I will highlight those angles on the figure so you can see what I'm talking about. Angle ACX is the exterior angle, and angles CAB and angle ABC are the interior opposite angles. So ACX, the exterior angle, equals the sum of the opposite interior angles, ABC plus CAB. That statement is true. So just to reiterate, angle ACX, the exterior angle, plus angle BCA equals 180 because those are the adjacent angles on a straight line. So from this equation, when we subtract angle BCA from both sides of the equation, we get ACX by itself equals 180 minus BCA. Now when we look at equation number 2, angle ABC plus angle CAB plus angle BCA equals 180, we can also rearrange that equation, subtracting angle BCA from both sides of the equation, so that on the right-hand side of the equation, we have 180 minus BCA. And on the left-hand side, we have angle ABC plus angle CAB. So ABC plus CAB equals 180 minus BCA, which is also equal to ACX from the previous equation. And I boxed that in purple to show you what I'm talking about. So from these two equations, therefore, we see that angle ACX equals angle ABC plus angle CAB. So the exterior angle equals the sum of the interior opposite angles. So I will relabel on my figure the ACX as the exterior angle and CAB and ABC as the interior opposite angles. These two theorems we've just worked on are summarized in the gray box on page 262, and we will use these theorems as we solve problems in geometry. For this problem, we find the value of x in the figure. So first of all, we notice that there are two sets of parallel lines and two triangles, one of which has two angles that are 65 degrees. So I will begin by extending the line on the bottom so that we can see that these two parallel lines are cut with a transversal. And I will also extend the transversal so we can take a different look at the figure. In doing so, I can see that there are alternate angles on a transversal. So I will label the angle of the triangle in the middle, the top angle, as A, and I can see that it is a alternate angle with the lower 65-degree angle, which means that A equals 65 degrees. And I support that assertion that A equals 65 degrees by writing the abbreviation for the theorem, alternate angles are equal. Now I take a look at X, angle X, and I see that it is also an alternate angle with the top set of angles, 65 plus A. And I write X equals 65 plus A. And I will highlight the angles to which I refer. So we have angle X, which I highlight with the orange marker. And that is an alternate angle with those two angles on top, 65 plus A. And the statement X equals 65 plus A is supported by the theorem alternate angles are equal, and I write the abbreviation for that in parentheses. Now I'm ready to substitute 65 for A in the equation below, so that I have X equals 65 plus 65. And I do that computation on the side. 65 plus 65 equals 130. Therefore, and those three dots mean therefore, X equals 130, and I box my answer. Next problem, form an equation in X and solve the equation. So first, we look at triangle ABC, and I will highlight triangle ABC for you. So if I ignore that middle line in that triangle, I can see that two of the angles are labeled with sizes, and so I will label the third angle as angle A. So from triangle ABC, we have angle A plus angle 2x, so A plus 2x, and the angle 2x I refer to as the one on the left, plus 2x plus 40, which is the angle on top. All those three angles added together equals 180 degrees. And I write the supporting theorem to the side. The angle sum of a triangle is 180 degrees, and the abbreviation is angle sum of triangle, which I write in parentheses. Now I'm ready to simplify the equation on top. So I have A plus 2x, which equals 4x, plus 40 equals 180. I continue to simplify by subtracting 40 from both sides of the equation. So on the left-hand side, I have A plus 4x plus 40 minus 40 equals 180 minus 40. On the left-hand side now, the 40s cancel, which leaves me with A plus 4x equals 180 minus 40. I do that calculation on the side, and I get 140. So now I have A plus 4x equals 140. I continue to solve for A by subtracting both sides of the equation with 4x. On the left-hand side of the equation, 4x minus 4x cancels, leaving a by itself, which equals, on the right-hand side, I have 140 minus 4x. So I cannot simplify this equation anymore at this point, and I will go back to the figure to examine triangle ECD, and I will highlight that triangle for you. So in triangle ECD, we see that angle A is the external angle to the triangle ECD. And we can also see that those two angles, one which is labeled X and the other one which is labeled 40, are the interior opposite angles of angle A. And since we learned previously that an exterior angle of a triangle is equal to the sum of the interior opposite angles, we know that A equals X plus 40. And I write that supporting theorem on the side using the abbreviation from the book. And I circle angle X and angle 40 to point out the interior opposite angles. So now we have two equations in A, which is A equals 140 minus 4x, and A equals X plus 40. So since both 140 minus 4x equals A, and x plus 40 also equals A, therefore 140 minus 4x equals x plus 40. And now we can simplify that equation and solve for x. So I begin by adding both sides of the equation with 4x. So that gives me 140 minus 4x plus 4x equals x plus 4x plus 40. On the left-hand side of the equation, minus 4x plus 4x equals 0, which leaves 140 by itself. And on the right-hand side of the equation, x plus 4x equals 5x plus 40. I continue to simplify by subtracting both sides of the equation with 40. On the left-hand side, I have 140 minus 40 equals 5x plus 40 minus 40. On the right-hand side of the equation, the 40s cancel, leaving 5x by itself. And on the left-hand side of the equation, 140 minus 40 equals 100. And to get x by itself, I divide both sides of the equation with 5. So that gives me 100 divided by 5 equals 5x divided by 5. On the right-hand side of the equation, 5 divided by 5 equals 1. 1 times x equals x. So I have x by itself. On the left-hand side of the equation, I have 100 divided by 5. I do that calculation on the side. 100 divided by 5 equals 20. So I have x equals 20, and I box my answer. The practice problems for this lesson are on pages 263 through 266 of the book. I suggest you take the time to do all of the problems. Please don't get discouraged if some of these problems require a lot more thought and contemplation before you can figure out how to tackle the problems. But know that you do have all the information you need to solve the problems. And please check your answers with those solutions on page 432 to make sure you did the problems correctly. I hope this video was helpful for you. Thank you for joining me at Do the Math America.